Okay, so we're going to be a Detective Zero. So it says over the last 2 days, but it is really right before fall break, we learned things about finding real zeros and imaginary zeros of a polynomial function. And then sometimes we were given the real zeros and we verified them using synthetic division or long division. Today, all we're going to be, we're going to be given some clues, but eventually all you're going to be given is the function, and you're going to do all of it on your own. All right, so we're not going to use our calculator on this side. We're just going to use these clues in our brain. So this is our function, x to the fourth minus 2x cubed plus 6x squared minus 32x plus 40. And so how many total zeros should this have? Yes. The total zeros matches the degree. That's the fundamental theorem of algebra. Now, if there's a repeated zero, you count it multiple times. So like if 3 was a zero with a multiplicity of 2, you would count that as 2 zeros to give our total of 4. So that actually comes up in this question. All right, we're given this table. So what does this table tell you about the zeros? What's a zero from the table? A zero is an x value that makes the function equal to 0. So what's the 0 on this table? 2. All right, so we know one of the 4. All right, clue 2 says that f of x is greater than or equal to 0 for all of x. Now that's kind of fancy. But what that means is that this function is graphed above the x-axis everywhere. It never falls below the x-axis. And that's important because I know that 2 is a 0. Is this graph going to be able to go straight through it too? If it's always graphed above the x-axis. It's not. So what's it going to do it to? It's going to bounce. So what does that tell you about the multiplicity? Do I remember that? It has a multiplicity of 2. If it bounces like that, it has a multiplicity of 2. So that's going to come into account later. All right, and our third clue is that f of x has at least one imaginary zero. Can it have only one imaginary zero? Do you remember about imaginary zeros? They come in pairs. Yes, they always come in conjugate pairs. So it technically has at least 2 imaginary zeros. Always has to have an even number of imaginary zeros. Okay, so those clues are helpful. So number 1 says, how many real zeros and imaginary zeros does f have? What do y'all think? I'll let you think about it for a second. There's a total of 4. There has to be an even number of imaginary. And we know we have this real zero with a multiplicity of 2. 2 and 2, good job. Right. And then these 2 real zeros, this problem has a lot of 2's. I should have changed it to be a little bit different. But x equals 2 is a real zero, but because it has a multiplicity of 2, you actually count it twice. I know that's weird, but for the fundamental theorem of algebra, that's counting as 2 zeros. Oh, that's also, draw the arrow down here, that's fine. So x equals 2 is one of the real zeros, and it has a multiplicity of 2. Because it bounces. All right, and then number 3. So I know that 2 is a 0, and so I'm going to find the remaining zeros by starting off and doing synthetic division with 2. So if 2 is a 0, you can put it in the box, and then go back to F and write your coefficients and your constant to the right of the box. And then multiply and add. Right, and if you say it's a 0, you should get a remainder of 0 or something went wrong. All right, so what we really want to do is get this down to a quadratic or a degree 2, because we can solve pretty much, we know how to solve every quadratic equation. We can factor it, we can do the quadratic formula, or we can just solve it. But this one is a degree 3, and we honestly don't know how to solve it. So what we'll do is we'll bring down these numbers we just got. We don't need to bring down the remainder of 0. This is kind of weird, but because this x equals 2 has a multiplicity of 2, I can actually do synthetic division with it again. Most of the time you get 2 different numbers for zeros, and so you'll just use the other one. So this is a kind of a unique situation. All right, so we'll bring the 1 down and then multiply and add. All right, we get another remainder of 0, so that was good. We did the right thing. All right, so we took a degree 4 and we did synthetic division twice, so this is down to a degree 2. So x squared plus 2x minus 10. And we want to know when that equals 0. Now we could try to factor it if we wanted to, but it would be a waste of time because we already know that there's 2 imaginary zeros. And when we factor a polynomial, it gives you real zeros. And so you could try, but there's no way it's going to factor if you get imaginary. So we can use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so in this case, b is 2, so we're going to do the opposite of 2, plus or minus the square root of 2 squared. I'm going to go ahead and make that 4, minus 4 times a, which is 1, times c, which is 10, divided by 2 times a, which is 1. So at this point, you can take in your calculator and just do 4 minus 4 times 1 times 10. Or you could actually do that in your head. So we all know 4 times 10 is 40. Do you know what 4 minus 40 is? Negative 36. So it's like you have $4, but you spend $40. So now you're $36 in the hole. All right, now this goes back to a little bit ago. So What is the square root of negative 36? Say it again. There isn't one? Okay. There is an imaginary answer. Do y'all remember that? So if there's a negative under the square root, there's going to be an I in your answer. So what's the square root of positive 36? 6. So the square root of negative 36 is 6i. All right, and then don't forget that you wait to the very, very end to simplify. So you have to have a whole heart to simplify. So a lot of people want to simplify here. It's only half a heart. So you have to have the whole heart to simplify. Is there a number that divides evenly into all of those numbers? Yeah. So we can reduce everything by 2. And that gives you 2 more zeros. Negative 1 plus 3i and negative 1 minus 3i. So that's 4. 2 real, these 2 count as 2 real, and then 2 imaginary. All right, and then part 4, we want to write f in factored form. So 4 zeros means we're going to have 4 factors. Now 2 is a repeated factor, so there'll be x minus 2 and there'll be another x minus 2. Now if you wanted to, totally up to you, you could write that as x minus 2 squared. However you want to write it, it doesn't matter to me. All right, and then we have to have a factor for each one of these. And they're both going to have an x first. And then you change the sign, change both signs. And so for the first one, it's going to be plus 1 minus 3i. All right, and then for the second one, it'll be plus 1 plus 3i. All right, so that's taken like a whole bunch of things we've learned and putting it all together. All right, and then number 5 says, and we're not going to really write this down, but it's fine. Were all the clues necessary to find the zeros? The first one was we needed to know a zero, so the table was necessary. This clue was necessary, so we would know there was a multiplicity of 2. I don't feel like this clue was necessary. It saved us time. So we knew when we got to this point, we knew we didn't want to try to factor it. We would go straight to the quadratic formula, but we could have found those without knowing that there was an imaginary zero. So I think clue 3 is optional but helpful. Okay, so on the back we're going to fill in the notes. So what they want you to do on here is they're either going to say to write in factored form, or find all zeros. But these are the steps you'll do to do both of those different things. All right, the first step is pretty easy. You just need a calculator to do it though. So the first thing we're going to do is find the real zeros. Whoa. Oh my goodness. What are the real zeros going to look like on the graph? X-intercepts, good. So we're going to find the real zeros or x-intercepts using a graph or a table, up to you. Then we're going to use synthetic division or long division if you like that better. I like synthetic better though. With the zeros. And then depending on if they're real or imaginary zeros, you can do one of three different things. We'll either continue factoring, use the quadratic formula, or solve. Okay, so when you guys are done writing those, if you'll get your calculator and put this equation into y1, please. Bless you. When you're ready, you can either look at the graph or you can look at the table. It's up to you. I prefer to look at the graph. Alright, so we can find the x-intercepts looking at the graph, or if you want to look at the table, you're going to need to scroll around until you see where the y is 0. So either way, we can tell we have a 0 at -3 and at 1. And then this tells you also to state the multiplicity. And so does it look like it just goes straight through at -3 and 1? Yeah, so these are going to have a multiplicity of 1. So the bouncing and bending, you won't really be able to see on the table. So I would say look at the graph first for sure. Okay, that's all we need our calculator for. It's just that very first step. All right, and then we're going to find the remaining zeros. So we can start with either one of these numbers. I'm just going to go ahead and do -3 first. And one thing I haven't asked you about that I should have, just whenever you're doing synthetic division, make sure that you don't need to fill in a 0. On all of these ones we've done so far today, none of the terms were skipped. But sometimes they do get skipped, so be careful. Alright, and then we got a remainder of 0, so that's a good sign. And then we'll do synthetic division with 1, and then these new numbers. All right, and we get a remainder of 0 again. All right, and then we started off with the degree 4. We did synthetic division twice. That should take us down to degree 2. And then the 0 here means that we're not going to have an x term, so that's okay. That actually makes it easier to solve. All right, so if it had been like what we had on the front side, let me move it real quick, where this one had an x squared and an x, we had to do the quadratic formula to solve it. But this one only has an x squared, so we could, but we don't have to. So we can just solve it for x by moving over that 25, dividing by -1, and then taking the positive and negative square root. Okay, so what is the square root of -25? Oh, I need y'all to shout it out loud and proud. 5i, yes. All right, how many zeros was this one supposed to have? Yes. And that's what we ended up with. We ended up with 2 real and then 2 imaginary, 5i and -5i. All right, so this g of x is also going to have 4 factors. You guys do the factors on your own, please. All right, what questions do you guys have so far? This last one takes a little bit of time. Even though it's multiple choice, it's got a lot of stuff we have to do. All right, so on number 2, h is a polynomial with 3 real zeros and 2 imaginary zeros. So there's 5 total. Which of the following could be an equation for h? So I'm going to start at the bottom and work my way up. So is it possible, is D possible? No. This only has 1 imaginary. There has to be 2 imaginary. Or an even number of imaginary. Actually, it has to be 2 imaginary. So this is not possible. So we can go ahead and mark it out. All right, what's wrong with C? It has 6. So it's not C. So we're having to decide between A and B. So it says there's 3 real zeros. Both of these have 3 real zeros. So there's 3 there, and this, because of that, this counts as 3. So we have to figure out if these are going to give you 2 imaginary zeros. So what I'm going to do is I'm just going to take this one, and I'm just going to see if I can factor it. So are there 2 numbers that multiply to get 12 and add to get 7? What do y'all think? What number is 3 and 4? Yeah. So this one actually has 5 real zeros, so it is not the answer. Our answer is going to be B. All right, what questions do you guys have? There's a lot to come back to.